Hello, welcome back to the video series. We continue to review the Understanding Construction Drawings textbook, and this video is about Unit 14, and this is drainage, insulation, and concrete slabs. So this unit is all about locating and explaining information for control of groundwater and also subsurface insulation and concrete slabs and the reinforcement to be used in concrete slabs. So all of the reinforcement for the concrete slabs must be in place before the concrete is delivered to the site. And let's actually go through a few things such as drainage, vapor barriers, insulation, concrete in the concrete slabs. So after the foundation walls are erected and before the excavation outside the walls is backfilled, and this is filling with earth to the finished grade line. Footings drain must be installed. So footing drains are usually perforated plastic pipe placed around the footings in a bed of crushed stone. If the site has a natural slope, the footing drains can be run around the foundation wall to the lowest point, then away from the building to drain by gravity. In areas where there is no natural drainage, the drain is run to a dry well or municipal storm drain. So again, please refer back to the textbook. There is a beautiful diagram showing the footing drain, and you can see the perforated plastic pipe pitched towards storm sewer, dry well, or some pump. And also you can see the filter fabric that is wrapped around the crushed stone or gravel. So at one time, clay drain tile was the most common type of pipe for this purpose. However, perforated plastic pipe is used in most new construction. Plastic drain pipe is manufactured in 10-foot length of rigid pipe and in 250-foot rolls of flexible pipe. An assortment of plastic fittings is available for joining rigid plastic pipe, and also when footing drains are to be included, they are shown on the wall section or footing detail. So again, there are pictures and sections showing that. The floor plan may include a spot elevation for the finished drain, or it may be necessary to calculate it from information given for the pitch of the concrete slab. Pitch of concrete slabs is discussed actually here as well. So we'll return back to that after vapor barrier and insulation. So stay tuned. Let's talk about vapor barriers. Another technique often used to prevent groundwater from seeping through the foundation is coating the foundation wall with asphalt foundation coating. At this point, subsurface work outside the foundation wall is completed, but backfilling should not be done until the superstructure is framed. The weight and rigidity of the floor on the foundation wall help the wall to resist the pressure of the backfill. If the backfilling must be done before the framing, the foundation walls should be braced. To retard the flow of moisture from the earth through the concrete slab floor, the drawings may call for a layer of gravel over the entire area before the concrete is placed. A polyethylene vapor barrier is laid over the gravel underfill. The thickness of sheeting is measured in mils. So 1 mil equals 1/1000th of an inch. And for vapor barriers, 6 mil polyethylene is generally used. So let's talk about insulation. In cold climates, it's desirable to insulate the foundation and concrete slab, and this insulation is usually a rigid plastic foam board placed against the foundation wall or laid over the gravel underfill. Rigid insulation under the floor may only be specified for the outer 2 feet of the slab. The heat of the building keeps the frost from penetrating more than 2 feet into the perimeter of the floor slab. So again, there is a section showing that, so please refer back to the textbook. Like all materials, concrete and masonry expand and contract slightly with changes in temperature. To allow for this slight expansion and contraction, the joint between the concrete slab and foundation wall should include a compressible expansion joint material. Expansion joints can be made from any compressible material such as neoprene or composition sheathing material. This expansion joint filler is as wide as the slab is thick and is simply placed against the foundation wall before the concrete is placed. So we continue our conversation about the concrete slabs. And so the area to be covered with concrete are indicated on the foundation wall or basement floor plan. And this is usually done by an area not given the thickness of the concrete slab and any reinforcement steel to be used. To help the concrete resist minor stresses, it's usually reinforced with welded wire or wire mesh. Welded wire mesh is sometimes abbreviated WWM and sometimes WWF for welded wire fabric. So the specs for WWM usually include all the details. So if the information is not on the drawings, then you can definitely find that in the specifications. So when floor drains are included or where water must be allowed to run off, the slab is pitched, which means sloped slightly. A note on the drawings indicate the amount of pitch. 1/4 inch per foot is common, and where there is any possibility of confusion about which the way the slab is to be pitched, bold arrows are drawn to show the direction in which the water will run. So again, you can see that in the drawings here. When floor drains or forms are set for pitched floors, it is necessary to find the total pitch of the slab. This is done by multiplying the pitch per foot by the number of feet over which the slab is pitched. So, for example, if the note on a concrete apron in front of a garage door indicates a pitch of 1/2 inch per foot and the apron is 4 feet wide, the total pitch is 2 inches. So that's easy to calculate. The proper elevation for the form at the outer edge or of the apron is 2 inches less than the finished floor elevation. So slab on grade installations may require electrical raceways to be installed in or just below the concrete slab in the crushed or gravel fill. These installations must be made so that they do not reduce the structural integrity of the concrete slab, and an oversized raceways or raceways in the concrete slab may cause the slab to crack and settle unevenly. So electricians should be present during concrete placement to observe and correct any damage to these electrical raceways. So all underground utility systems must be coordinated prior to starting installation, especially in commercial and industrial buildings. And the service entrance section may have up to 6 sub distribution sections or panels located throughout the building. electrical feeders are required from the electrical service entrance section to these sub-distribution sections or panels. The electrical installation must be laid out around the other utilities, with the other utility layouts normally having priority. The other utilities to be coordinated may include plumbing, fire sprinklers, heating and air conditioning or HVAC, and specialty systems. So just because the wires are really flexible, they can go around other utilities. That's the only reason. But still, coordination is required. So that was it for our Unit 14. Thank you so much for watching. I will see you in Unit 15.